Hello, y'all. My name is Mr. Laughlin, and I'm gonna be your science teacher this year. I'm gonna focus on chemistry with you. And my understanding is that you have had some chemistry last year, and I've been made aware of what you studied, but I would like to do some revision at the beginning of this year, just to make sure we're all on the same page. So today, that's what we're gonna do. We're gonna kind of go through like the first chapter in the book. We're gonna go through it really quick though, just to refresh. Also, just some things about me. That's a picture of me, obviously. I have family, a wife, and a kiddo. He's 4. We're super excited to be in Italy. Hopefully, I'm gonna be there very soon. Um, but we can't wait to be there. Yeah, and let's get started. So the first chapter is about solids, liquids, and gases. So phases. Um, what do they do? How do they transition? What do we know about their energies? All that kind of stuff. So we're gonna kind of speed run this chapter. We'll go real quick through all of it, and then after that you'll have an assignment, and I want you to fill it out, and it's going to help me see where you all are at. So I know where we need to go from here. So, solids, liquids, and gases. They each have their own properties, right? Solids have fixed volume, they keep their shape, they have boundary. Liquids take the shape of their container, and their particles slide past each other, and then gases fill up whatever container you put them in. They have no fixed volume, and they have no boundary, right? So their particles are all arranged slightly differently and will do different things because they have slightly different properties. So, my question for you, and perhaps you can pause the video and write your answers into your notebook. I have two questions. So, what forces are holding solids and liquids together? What force or forces? And of the three states of matter, which state has the least amount of force acting on its particles to keep it together? So take a moment, think about that, pause the video, write down your answers in your notebook, and then I will explain. Okay, so the first question. What force or forces are holding solids and liquids together? The correct answer is electromagnetism. Electricity and magnetism, they are part of the same force. Um, Sometimes it's easier to just think about the particles as being like little magnets that are attracted or repel each other, because that's how we think of magnetism. But it is one big force altogether, and it is electromagnetism that holds them together, right? There's positive protons, negative electrons. That's electromagnetism. Of the three states of matter, which state has the least amount of this force acting on its particles? And that would be a gas, right? They fly around. They are not close to each other, so the forces are not being exerted constantly. All right. So let's talk about particle arrangement. So solids have regular organized patterns, right? Sometimes they arrange in a lattice, which is like a very organized structure. Crystal lattices are really fun to look at, like a diamond is a nice crystal lattice. Liquids, the particles are randomly arranged. They slide past each other, and gases, the particles are also randomly arranged, right? They're not even sliding past, they're bouncing off and bouncing off the walls. They have so much energy. They've broken free from those intermolecular forces, which are electromagnetic, and they can now fly all over the place. When we think about the phases, we can change between them, right? And that has to do with how much energy that our object or our particles have. So we can think about our energy as heat energy, right? That will be helpful as we think about changing states. So solids have the least amount of heat energy. Maybe we can use water as an example. Like ice is cold, right? You heat up ice, it melts and becomes a liquid water, right? You heat up that liquid water even more, it will boil, which will then become a gas. So a gas has the most amount of heat energy, right? As you begin to cool a gas down, it will condensate, so it comes back together and becomes a liquid, right? As you cool it down even further, it freezes into a solid again. So the changes of state happen because of energy, right? Let's go back real quick. You should know like specifics about all these things. Again, we're kind of just going through all this just so we can remember it, so we can revise it. And so the effects of temperature and pressure on a gas. Um, these are kind of intuitive, right? As the temperature increases, the volume increases, right? You give a gas more heat energy. If we go back here, right, increase its heat energy, it has more energy. More energy means more volume in this case, right? It's gonna push against this piston and create more volume. Um, as you decrease the temperature, the volume decreases. You can even see this, right? Decrease heat energy. The gas is taking up all the volume, and then it becomes a liquid, so it takes up less volume. Decrease the heat energy more, and then it becomes a solid, right? So this is true for the effects of temperature on a gas. Um, pressure, right? As pressure increases, volume decreases, right? You put more pressure on your gas, the volume will get smaller. As the pressure decreases, the volume increases. Uh, so let's talk about the kinetic particle theory. We know that matter is composed of tiny particles, and those tiny particles are in constant motion. Yes, even the solids are moving all the time. They have energy, they still have heat energy, which makes them move, right? As the temperature increases, particles gain more kinetic energy. You can see this. These are vibrating in these fixed positions. Liquids have more energy. They're moving past each other, right? You can think about this as like a crowded room of people that's all moving past each other. Gases have the most. They are bouncing around everywhere. They're moving very quickly. Um, and to keep this in mind, keeping this in mind is important too. Particles are attracted to each other through intermolecular forces. So this is basically different electromagnetic interactions, right? So different interactions of those positive and negative charges. Um, and they're attracted to each other because each particle has a charge, right? It has protons and electrons, and positive is attracted to negative. So these forces keep solids together, keep liquids close to each other, and have to be broken free from to become a gas, right? So these are experiencing intermolecular forces on a much bigger scale than a gas because a gas has gained enough heat energy to break free and do its own thing to race around its container. So when we think about melting, right? Like ice is heated, the particles gain enough kinetic energy to overcome the forces holding them together, allowing them to move freely and transition into the liquid state. So the ice, you give it enough heat energy, which is, yes, kinetic energy. Heat is a form of kinetic energy. Um, it will overcome those intermolecular forces and it will start to move past itself, right? It will melt and become a liquid. Freezing is the opposite, right? You take away the heat energy, the kinetic energy, and the particles slow down. At the freezing point, those forces of attraction overcome the kinetic energy of the particles and they get held in a fixed organized pattern. Here's some nice, beautiful crystals. Boiling. When a liquid is heated, the particles move even faster, weakening the bonds holding them together. At the boiling point, the particles have enough energy to break their bonds, and the liquid turns to gas. So the liquid phase, they still are experiencing those intermolecular forces, right? The liquid is being held together in some sense. If you give them enough energy, right, they will break free and become a gas. Evaporation. So, evaporating is an interesting transition because whereas materials have a boiling point, like water boils at 100 degrees Celsius, evaporation can happen at many, like a range of temperatures. So, evaporation happens when some of the particles near the surface of the liquid gain enough kinetic energy to break free of their bonds and become gaseous. So, similar to boiling, right? But it's just some of the particles at the top or at the boundary, right, get enough energy instead of like transferring enough heat energy to the entire volume of the liquid to break free. It's just a couple particles up at the top. Here's a nice example of evaporation, right? You put your laundry out to dry and the sun gives it some energy. Obviously, it's not reaching the boiling point of water, but it's still enough energy for the water to slowly evaporate off of it. Condensing, this is another good picture for condensing. The gas particles lose energy, usually due to a decrease in temperature, and come together to form a liquid. As they slow down and come close together, the forces of attraction between the particles form. So at night, right, the temperature drops and the water that's in the air starts to condense on the grass, right? It comes together and comes out of its gaseous form and into its liquid form.